All right, everyone. Time for FRQ number 6 from 2019. I'll admit the first pass I made at this FRQ, I totally botched part C. So this one definitely has a little bit more going on. Part C was also the infamous kind of most difficult question for students last year. So anyways, with that being said, let's dive in. It doesn't start difficult, thankfully. If you want h prime of 2, then just realize that they gave you the line that is tangent to g and h at 2. And the tangent line at 2 for h is going to contain the slope at 2 for h, because the tangent line has to use the slope or the derivative of that function. So h prime of 2 is just the slope of the tangent line, which is 2/3. And done. Up next, for part B, if we let a be that given function and we want a prime, the big key to getting your first point is noticing that there's a product rule going on here. So I'm going to think of 3x cubed as one entire function as opposed to 3 and then x cubed. So we have 3x cubed and h of x. So the product rule, for me, I usually derive the first, so now I have 9x squared times h of x, which hasn't changed yet, plus keep the 3x cubed and derive the h of x, which is h prime of x. And then from there, they want a prime of 2. And so that's going to be 9 times 2 squared times h of 2. And that first sentence, it's super important. It tells you h of 2 is 4. So that means h of 2 is 4. Plus 3 times 2 cubed times h prime of 2, well, we just found that in part 1, that's 2/3. I guess one important thing to note here is, let's say, for instance, you had no idea what to do on part A and you skipped it. Well, part B, if you kind of notice, you still need to know what that is. So, worst case scenario, let's say you try this and you realize you need h prime and you realize you don't have it. Don't stop. Make up an answer for this, however crazy it is, and then use that answer and continue on. AP will usually continue. If you have a past result that's incorrect, but you continue using the correct method, you can still get credit for it. So if you skipped part A and you realize that's what you need right here, make something up for part A so that you can at least continue on and get part B correct. Anyways, moving right along, if you work all this out, this is going to be 9 times 16, which is 144, plus, what I'm going to do here is notice that you'll eventually have 3 over 3, which will cancel. So you have 2 cubed times 2, which is going to be 16, so the answer is 160. Alright, up next, it's time for part C. This is the most difficult question for most students. And so hopefully you've read it. If not, take time to right now. But here's step 1. If L'Hopital's rule can be used, and so you should kind of be writing some of this down, that means the limit as x approaches 2 for h of x has to be, I guess in this case, if you notice, well, I guess it has to be indeterminate form. And so the idea is, if you plug in 2 by direct substitution, f of 2 all cubed, if you notice, this is 0 over this. And if L'Hopital's rule is going to be used, well, if you have 0 in the numerator, L'Hopital's rule either needs 0 over 0 or infinity over infinity. So in other words, if this whole numerator is 0, then your entire denominator has to be 0. So whatever 1 minus f of 2 cubed is, that has to end up being 0. And so what does that mean? Well, it leads us to finding the first part of our work. So I'm going to write it like this. Since L'Hopital's rule can be applied, 1 minus f of 2 all cubed, the denominator, must be 0. We have to get that indeterminate form to use L'Hopital's rule. And so if that's true, well then 1 minus f of 2 cubed equals 0. And I'll let you work out the algebra, but long story short, that means f of 2 has to be 1. So now we've answered part 1. We now know what f of 2 is. All right. Now from there, the idea is, how do we know f of 2 is 1? We're actually not quite done yet. We have to verify one other thing. Since f is differentiable, it is continuous. And if it's continuous, here's the big key, the limit as x approaches 2 for f of x equals f of 2. In other words, it wasn't guaranteed that f of 2 is exactly 1, but because the limit, or I guess I should say, the limit as x approaches 2 of f of 2 isn't guaranteed to be 1 yet, unless we can totally explain that because we can take the limit of f and f is differentiable and continuous, then the limit we get for this is the actual value of the function at that point. So that fully satisfies why f of 2 is 1. Up next, we have to figure out what f prime of 2 is. So in other words, since this is in indeterminate form, we're now going to apply L'Hopital's rule. And that means we're now going to be looking at the limit as x approaches 2 of, and that means we have to derive the numerator individually, which is going to be just 2x, derive the denominator individually, which is going to have a chain rule in it. Just be careful that you don't include the 1 when you derive it, because 1's going to derive to 0. So you're going to end up with negative 3 f of x squared. You're going to use the power rule on f of x, but you also need to derive the inner contents, so you'll end up with an f prime of x as well. So this is the limit of 2x divided by negative 3 all of f of x, squared, because the power has to reduce, times f prime of x. All right. From there, let's see what we have here. We now have 4 over negative 3 times 1 squared times f prime of x. And now what we should say is kind of the same argument. We are trying to find the limit of h of x, essentially. And so same argument, since h is differentiable. They're both twice differentiable, but you just have to say differentiable. It is continuous. Therefore, the limit as x approaches 2 for h of x is going to be equivalent to the value of h at the limit we want. So, the limit of x approaches 2 for h of x has to be 4. And so what does that mean? It means now we can take this expression and set it equal to 4. So we now have 4 is equal to 4 divided by negative 3 times 1 squared times f prime of x. And if you do some algebra here, or if you just kind of look at this, how does 4 equal 4 over something? Well, this whole something has to be equal to 1. So this implies that negative 3 times 1 squared, I'm going to quit writing that because that's just 1. So negative 3 times f prime has to be equal to 1. And so now I know that f prime of 2, because we're taking the limit, we're doing some direct substitution here. And so that means f prime of 2 has to be equal to negative 1/3. This question is a wild ride. Make sure you read the scoring guideline. Hopefully you already have before this video, so you kind of knew what was coming. Hopefully this makes it a little bit clearer, all those crazy steps that you had to take. All right, one more part It is known that g of x is less than or equal to h of x from 1 to 3. Let k be a function satisfying that crazy thing. Is k continuous at x equals 2? Justify your answer. Honestly, I gotta look at the scoring rubric. Let me tell you what I think it is just based on the answer. Oh, wait, never mind, sorry. Hey everyone, this is a squeeze theorem question. Whoever thought this would show up? But the idea is k continuous at 2? Well, we know that g is continuous and either less than or equal to h all the time from 1 to 3. So let me draw a picture of where this problem's going. Here's the value 2 that we care about. Or sorry, here's the value 4 that we care about. The y value 4. And here's the x value. So I should put the line right here. This is the problem. Not the problem, but again, I'm trying not to look at the scoring guidelines before I actually do the problem with you, so that I'm kind of in the hot seat as well. I should have 15 minutes, you should have 15 minutes. But the difference between you and me is hopefully that I'm not studying these questions or studying the concepts. I'm just kind of quickly going through as I see them, trying to recall all my calculus knowledge. Hopefully you're reviewing more actively than I am, so you're actually going through these faster than me. That is the goal, because I'm not going to review. I still have the knowledge in the back of my head somewhere, but with you, you should be able to do these faster than me eventually with enough practice. So, anyways, so from 1 to 3, we know that g is always less than or equal to h. We also know that at 2, g is 4, and h is 4. Now, maybe you can see the picture that's going to go on here. I'm going to draw a possible scenario here. This is g of x on the bottom, and if h of x is either greater than or equal to, you can see h of x looks like this. Now again, the only thing that really matters is this going on right here. All right? So is k continuous at 2? Well, just look at it. Since does it have to be continuous at 2? Well, yeah, short answer, I think I'm going to wrap it up. Here's how I'm going to say it, and then I'm going to read the scoring guidelines. Since you can find g prime of 2, and you can find h prime of 2, in other words, since both of those are continuous, or in other words, since you could take the left-handed limit for each of those, the left-handed limit has to exist for k. Since you could take the right-handed limit for g and h, the right-handed limit has to exist for k. And since you have an exact value for g and h, the exact value has to exist for k. So since the left, the right, and the actual value of the function all agree, k must be continuous at 2. So that's how I'm going to get away with it, saying it verbally. Let me see if I am right. Because g and h are differentiable, they're continuous, and so the limit of g is 4, the limit of h is 4, and because k is squished in between them, the limit of k must be 2 as well. Also, same idea. So therefore it is continuous. So you can take the limit of g and h and get 4, therefore the limit of k must be 4. You can just actually plug in the value for g and h and get 4, and therefore k of 2 must be 4 as well. So there.